Hey, welcome back to another week of working with fractions and mixed numbers. And this week we are taking all that we have learned about calculating with the fractions and applying them to real world situations that we call practical application or word problems. So, the thing that I've noticed working with students is that the hardest part about word problems is deciphering what operation to do after reading this situation or problem. So, the best way to tackle that is to really get comfortable with the keywords that direct you to which operation you're going to do based on what you see in your word problem. So, that's where we're going to start. We're going to look at the word problem keywords for each operation. Okay, so for addition, obviously, if you see the word add or plus, you know you're going to be doing addition in your word problem. But you'll also see things like total or in all or altogether. So, any keyword or suggestion that you are combining things, you are going to be dealing with addition. All right, subtraction. So, subtraction, you might just hear it say exactly that, subtract or take away. Often you will hear find the difference or minus. You'll hear things like decrease or fewer. And how much is remaining or left is another key one. So anytime you hear a keyword that is suggesting that there's a comparison of some kind, and usually it's trying to find the difference between things, then you are dealing with subtraction. So comparing, you're dealing with subtraction. All right, multiplication. So for multiplication, remember multiplication is fast addition. So sometimes they'll use words and phrases that could apply to either one. For instance, if you say altogether, that's another clue for multiplication. But there will be keys in the word problem that will suggest that you are adding something very quickly or it's growing very quickly. And that will suggest that it's multiplication or it's growing by groups instead of growing by individuals. Product is the answer to a multiplication problem. So if they say, what's the product of, you know you're dealing with multiplication. And if you hear times or twice, twice is a specific multiplication problem, suggesting we are multiplying by 2. If you hear factor, factor are the numbers that are multiplied together to get the product. So if they're talking about a factor, you know you're talking about multiplication. If they talk about area, area requires multiplication in order to find it. It's length times width for a rectangle. So if they're talking about area, they had the operation of multiplication. And the most popular one that you will see often is this keyword here of. If you're looking at something of something else, it is talking about multiplication. All right, so fast growth, if you talk about fast growth or groupings of things, that would be your multiplication keys. And last, division. So for division, if you hear quotient, it's the answer to a division problem. So quotient would be signaling that you need to divide. If they talk about sharing something or some share of something, it is talking about a part of something, which is another key word if you're looking at parts or pieces. Sounds like a fraction, right? And remember, fraction are just little baby division problems. If you hear out of, instead of just of, you hear out of. That would be suggesting that they are grouping or separating things. If you hear separate, that's another good keyword for division. Each, now each is a little tricky because each could mean division or multiplication. So you're going to have to see whether or not they are making something smaller, then it would be division, or if they're making something bigger, it would be multiplication. So the biggest thing about division is it's splitting things and it's grouping things. And if you hear any of those keywords suggesting that you're breaking things apart or grouping things, you know you are dealing with division. All right, and then just one more quick run through for how you do the calculations for each of these operations with fractions. So with all fractions, if you are dealing with mixed numbers, remember that changing mixed numbers to improper fractions using the C method is always good practice because you have to do it for multiplication and division. It's highly suggested for subtraction, so you might as well go ahead and convert any kind of mixed number to an improper fraction, because really the only one that it's beneficial for in time saving is addition. But that's your choice. So convert mixed numbers is always kind of a first step. All right, and then I'm going to just draw a little C to help you remember how to do that. All right, so for adding fractions, you are going to create like fractions. You cannot add or subtract if they have different denominators. So creating like fractions is going to be the first step you have to do. And then you are going to add. You're going to add just the numerators, though. That is a big key. You are not able to add, or you will not want to, because that means you're cutting your pieces into smaller pieces. Add the numerators only, and then with every step, you're going to simplify. All right, let's look at multiplication. For multiplication, you are going to multiply straight across. And we love multiplication because it seems to be the easiest, but you're going to go straight across. And that is going to be both the numerator and the denominator, okay? So with multiplication, you get to do both. And then you are going to simplify at the end. All right, if we are looking at subtraction, whoops. Subtraction, how we subtract fractions. Of course, we're going to create like fractions first, and then you're going to subtract the numerators only. And that's going to be a major key because you're not allowed to subtract the denominators. If you had made them like fractions, subtracting the denominators will make it go to 0. So it means you have no whole parts at all. And then simplify. And finally, with division, remember my little trick of dividing little baby division problems is so tricky. I'm going to need to stop and take a break and have a snack, a KFC snack. And that is your biggest clue for what to do with division. You're going to keep the first number, change to multiplication, and flip the second number. And then you multiply straight across both numerators and denominators. So you'll see that what they have in common with multiplication and division is you are operating with both the numerators and the denominators. And with addition and subtraction, you only add or subtract the top number or the numerators. All right, so let's take a look at some word problems, and we will practice using these keywords to solve the problem. All right, so I always start by highlighting my numbers and my keywords for each word problem, and it just helps my brain to see exactly how to set up the problem. So I'm going to start by highlighting this first number that I see. Now remember, fractions are numbers. They're just small little baby numbers, okay? So I see 1/4, and I keep going, and I see 24, and I don't see any more numbers. So now it's time to read it and try to find the keyword for the operation. So Troy uses 1/4 of a cup of icing for each cupcake. Well, we know that each is a keyword. If he needs to make 24 cupcakes, how much icing does he need to make? So we talked about each, and that each could mean either multiplication or division. They're opposite operations of each other. But we also said that if our situation is growing, it's going to be multiplication, or if it's reducing or it's being split into groups, it would be division. So are we going to be growing this fourth of a cup of icing, or are we going to be cutting it into separate groups? And this is definitely going to be growing, because we are going to be multiplying it to make 24. So it's getting bigger. All right, so we're going to use multiplication. So now what I do is I just start writing down what I have been given in the problem. So we have 1/4, and we're going to be multiplying my other number, 24. And that's exactly how you set up this problem. If we have 1/4 of a cup for each cupcake and he needs to make 24, then we're going to be multiplying it by 24. Now we have a fraction and a whole number, so we need to make them both fractions. So we're going to take our whole number and put it over 1. And now we have two fractions. With multiplication, you just go straight across. And you might be seeing that those of you who knows how to cross simplify, you could cross simplify right here. I'm going to show it both ways, but I'm going to go right now just straight across. 1 times 24 is 24. And 4 times 1 is 4. And then we would reduce this. So 24 divided by 4 is a whole number. And we get 6. And 6 times 4 is 24, leaving us nothing left over. So the answer to our problem is he's going to need to make 6 cups of icing in order to have enough to cover 24 cupcakes if he always uses 1/4 of a cup per cupcake. Now, if you wanted to see that quick cross simplification, I'm going to show you here. We see that if you look across, 4 does go into 4, and you can pull out 4 from each. So 24 divided by 4 is 6. 4 divided by 4 is 1. And so now when you multiply, it's 1 times 6 and 1 times 1, which we see is 6. So you get the same answer. All right, let's look at the next problem. So Troy only has 2 1/3 cup. Okay, so this is the whole number here, 2 1/3. And how many cupcakes can he make to evenly distribute his icing and make sure that each cupcake gets 1/4 of a cup of icing? All right, so he's still sticking with that 1/4 cup of icing. So those are our two numbers. And then the operation, and if you heard it when I read it, evenly distribute would be the key, telling us that we need to divide here. All right, so that's exactly what we're going to do. We're going to take our first number, and I'm going to write it like a mixed number, like we're used to seeing it. And we're dividing the total amount that he has by how much would go on each cupcake to find out how many cupcakes he's going to be able to make. And there may be some left over as well, but we need to see exactly how many cupcakes he can make with that 1/4 cup proportion. All right, so we have a mixed number here. We cannot divide with mixed numbers, so we are going to convert. So 3 times 2 is 6, plus 1 is 7. Put it back over its thirds that we were dealing with. So 2 1/3 is the same thing as 7/3. And we're going to divide by 1/4. And nothing needs to happen with that 1/4. But we have division. So how do we divide fractions? We're going to keep change flip. Okay, so we're going to keep the 7/3, change division to multiplication, and flip that second fraction. So the inverse of division is multiplication. The inverse of 1/4 is 4/1. And now we can go straight across. Look and see, can you cross simplify? Not this time. So we're going to go straight across. So we have 7 times 4 is 28. 3 times 1 is 3. And we need to get it back into mixed number form. We don't want to leave it improper. So 28 divided by 3. We get 9. 9 times 3 is 27. That leaves us 1 left over. So 1, put it back over 3. 9 1/3 cupcakes. So obviously, to answer the question of how many cupcakes can he make with this amount of icing, we're not going to coat just a third of a cupcake. So we're going to say 9 cupcakes is our final answer. All right. Sharon is making a blue and pink dress and needs a total of 6 2/3 yards of fabric. So here's our first number, 6 2/3. If she has 4 3/5 yards of pink fabric already, how much blue fabric will she need? Okay, so she already has some. She has a total of this amount. She has some already, and we need to find the remaining amount. So it doesn't specifically say remaining, but we know that we are looking for what we need to find from, or the difference from the total and what she already has. So that would be subtraction. All right, so let's go ahead and write our numbers in. We have 6 2/3. We're going to subtract what she already has of 4 3/5 to find out how much she still needs. Okay, this is subtraction, so it's highly recommended to go ahead and just convert. So we're going to do that. So 6 times 3 plus 2, we're going to get 20 over 3. And I'm actually going to come over here. So 20 over 3. And then let's convert this. 4 times 5 is 20, plus 3 is 23 over 5. And I'm going to do it vertically here, because we see that we do not have like fractions. So we are going to need to make like fractions first. So I'm going to multiply by 5. What I do to the bottom, I do to the top. And down here, I'm going to multiply by 3. And we're going to see that we're going to have 15ths for both. Now they are like fractions. So 23 times 3 is 69. And 20 times 5 is 100. So now we can subtract because we have like fractions here. And we're not going to subtract the bottoms, just the numerators. So 100 minus 69, we get 31. That's improper. So 31 divided by 15, it can go into it twice with 1 left over. So 2 and 1/15 yards of blue fabric is needed. All right. Last one. Sharon wants to add trim to the neck and on the 2 sleeves. So here's a number. I'm going to underline that one. She will need 1/9 of a yard for each sleeve, and 2/3 of a yard for the neck. How much trim will she need in all? So we see this keyword here, in all. And we also saw another one up here, each. Okay, and there's 2 ways to solve this. Remember, multiplication, which is what this is here, is fast addition. So you could either set this up to where you have 1/9 plus 1/9, and that would be the 2 sleeves that they were talking about, which is why I didn't color this in, because it's just talking about how many they're going to be. Plus the yardage for around the neck, which was 2/3. And you could add all these up to find out the total number of yards for the trim. The other way you could do this, since these are identical and you're adding 2 of the exact same thing, you could set it up with multiplication. And there's where that 2 comes in. So we have 1/9 times 2, because there's 2 sleeves, plus 2/3. Okay, so I'm going to choose to do it this way here to practice both multiplication and addition. So we always know order of operations. We're going to do our multiplication first. Multiplication, we go straight across. 2 times 1 is 2. 9 times 1 is 9. So obviously up here, if you did this, 1/9 plus another ninth is 2/9. So that is accurate there. And then now we add our 2/3. So I am going to set them up vertically again. 2/9 plus 2/3. All right, we do not have like fractions, so we are going to have to make equivalent fractions first. But we don't need to change this top one because we can make this one go to something over 9 because 3 times what gives me 9? 3 times 3, what we do to the bottom, we do to the top. 2 times 3 is 6. So our new problem is, I'm going to separate these a little bit. Okay, so now we have 2/9 plus 6/9. So 2/9 plus 6/9 will give us 8/9. And then we check, can this be simplified? And it cannot. So we know that we're going to need 8/9 yards of trim for this dress. And that is it. So again, the best suggestions I can give you for solving word problems, whether they're with whole numbers or they're with fractions, is to highlight the color or highlight the numbers that you're going to be using in your problem and highlight those keywords that tell you which operation to do, and then just start solving. So I hope that this was helpful, and good luck practicing this concept now on your own.